All right, let's look at the three cases again. The first case is that we have intersecting lines. And we're going to look at what this means algebraically and what this looks like graphically. So intersecting lines are just going to see two lines crossing an ordered pair. If you solve it algebraically, you're going to get some value for x, you're going to get some value for y, and then you're going to put them together in your ordered pair for your solution. Okay. The next case would be if your two lines were parallel. If your two lines are parallel, you're just going to see two lines that are, a little bit more than that, roughly in the same direction. That was a pretty bad picture. But you're going to see two lines that are heading off in the same direction. There we go. And what that's going to look like is something like 0 equals 10 or 4 equals 8, something that's not true. And since it's not true, the correct answer in that case is going to be no solution. Okay. And then the last case is the dependent or identity case. Dependent or identity. And in the identity or dependent case, the picture is going to look like a single line because both lines are actually right on top of each other. And algebraically, that's going to look like 0 equals 0 or -2 equals -2. It's a true statement. Since it's true, the answer is infinitely many solutions or infinitions. Okay, so let's compare some of the pros and cons. If I'm graphing, it's nice to be able to see the solutions, but the disadvantages are that if the solutions aren't whole numbers or if they're too large to be seen in the graph, it's going to be impossible to tell exactly where they are. So it's a pretty big disadvantage. Now for substitution and addition, they both give exact solutions, so that's an advantage. Disadvantages is you can't see the solutions, and for substitution, there could be a possible disadvantage about extra work if none of the variables have a coefficient 1. So sometimes it's going to be better to use addition, and sometimes it will be easier to use substitution. Both of these methods we're going to alternate back and forth between as the problem dictates. Okay. Graphing, though, is pretty unreliable, especially for problems that have large solutions or even fractional solutions. Alright, and let's look at the last example here. Alright, this is a problem about loans. L is the amount of student loans in T years since 2000. So we've got private loans and Stafford loans. So I'm going to use either substitution or elimination to predict when the amount of private loans will be equal to the amount of Stafford loans. So I want to figure out what the solution is to this system. Alright, now which method should I use, substitution or elimination? This problem is not set up to use elimination because I'm not in the columns of x, y, then the equals and the number, although I am in columns, they're not in the exact right form. That's going to lead me to think about substitution, and for substitution, I have to be able to know what one variable is equal to, and I do. I know that L is equal to 3t minus 1, so I'm going to plug that in here for L. So my substitution step is going to leave me with 3t minus 1, I'm not just writing the point O's, equals 2.3t plus 15.4. This is actually set up very well for the substitution method. I know what L is equal to in both of them, so I'm going to just plug it in and solve. Let's go ahead and subtract the 2.3t from both sides. 3 minus 2.3 is going to be 0.7t minus 1 equals 15.4. Add the 1. I'm going to get 0.7t equals 16.4. I'm going to use my calculator to divide both sides by 0.7. So t equals 16.4 divided by 0.7. 23.4, we'll say. Alright, so that's only part of it. Remember, I need to find the L value also. So the L value, one of the equations said it was 3t minus 1. So let's figure out what the L value is. So 3 times 23.4 minus 1 is 69.2. All right, and let's interpret this. That t value is a year, and it's the years since 2000. So since 2000, that would be in the year 2023. Both types of loans, since this is when they're going to be equal, so both types of loans, let's see, are we lending? And that's the amount of the loans. So both types of loans have an amount of, this is in billions, have an amount of and we say it's 69.2 billion. So again, the interpretation piece is important. Putting the units on that 23, actually putting the 2023 in there, and making sure that our units on the 69.2 are $69.2 billion. Those are the important parts right here.